Ever looked up at the night sky and wondered if you might see something truly spectacular? A star exploding, perhaps? Well, tonight we're talking about a star that does just that, again and again. It's nicknamed the Blaze Star, and it's one of the most fascinating objects in our galaxy. Unlike most stars that go out with one final, cataclysmic bang, this one is a cosmic drama queen, putting on a show for us roughly every 80 years. It's a star that, quite literally, cannot be killed. Imagine being an amateur astronomer back in May 1866. Your name is John Birmingham, and you're just enjoying a quiet evening, gazing at the familiar constellations. Suddenly, you spot something new. In the constellation known as the Northern Crown, a brilliant star has appeared out of nowhere, shining as brightly as Polaris, the North Star. You've just become the first person in modern history to witness the incredible eruption of the Blaze Star, a celestial event that had been waiting patiently for its moment in the spotlight. So what's actually happening up there? Why does this star keep exploding? The Blaze Star isn't a single star at all. It's a binary system, a cosmic dance between two very different partners. One is a red giant, a huge, bloated, aging star. The other is a white dwarf, the superdense, collapsed core of a star that has already lived its life. They're locked in a gravitational embrace, orbiting each other so closely that the white dwarf's immense gravity is constantly pulling material, mostly hydrogen gas, from its larger companion. Think of the white dwarf as having an insatiable appetite. It's just sitting there, siphoning a steady stream of gas from the red giant. This gas piles up on the white dwarf's surface, forming a dense layer. As more and more material accumulates, the pressure and temperature at the bottom of this layer skyrocket. It's like pumping air into a balloon. You pump, and the pressure just keeps building, getting tighter and tighter. You know something has to give, and eventually, it does. The temperature reaches a critical point around 10 million degrees Celsius. At this mind-boggling temperature, the stolen hydrogen suddenly ignites in a runaway thermonuclear fusion reaction. The result is a colossal explosion, a nova. In an instant, the star system flares up, becoming hundreds, even thousands of times brighter than it was just moments before. It's this sudden, brilliant flash of light that John Birmingham saw in 1866, and that we can still see from Earth today. Now, you might be thinking, doesn't an explosion like that destroy the star? And that's the crucial difference between a nova and its much more famous cousin, the supernova. A supernova is the final death-dealing explosion of a massive star. When a supernova happens, the star is completely obliterated. It's a one-and-done event. But a nova is different. It's more of a surface-level event. The explosion is incredibly powerful, but it only blows off that outer layer of accumulated gas. The white dwarf itself, the core of the star, remains intact, completely unharmed by the blast. Think of it like a party popper. You build up the tension, pull the string, and pop, a burst of confetti and noise, but the popper mechanism itself is still there, ready to be reloaded. That's our white dwarf. Once the nova explosion has faded, it gets right back to work, pulling more material from its red giant companion. The whole cycle begins again, slowly building up fuel for the next eruption, decades down the line. This is why it's called a recurrent nova. It's a celestial cycle of theft, pressure, and explosion, doomed to repeat itself over and over. During one of these outbursts, the Blaze Star can become up to 1,500 times its normal brightness. It goes from being a dim, unassuming star, invisible to the naked eye, to one of the brightest objects in its patch of sky. For a few days or weeks, it blazes with incredible intensity, a temporary beacon in the Northern Crown, before slowly fading back into obscurity. It's a dramatic performance that has captivated astronomers for over a century. Each eruption gives us a chance to study these extreme physics up close, to understand the life cycles of stars and the violent processes that shape our universe. The last time the Blaze Star erupted was in 1946. Doing the math, that means we are right in the window for its next performance. Astronomers around the world are watching it closely, waiting for the telltale signs that it's about to blow again. It could happen next year, next month, or even tonight. It's a rare opportunity to witness a stellar explosion with our own eyes. So, next time you're under a clear night sky, take a look towards the Northern Crown. You might just be lucky enough to catch a glimpse of the star that refuses to die, the incredible Blaze Star, putting on its once-in-a-lifetime show. Thanks so much for joining me on this cosmic journey. If you enjoyed learning about the Blaze star, make sure to hit that like button and subscribe for more adventures into the wonders of our universe. We've got so much more to explore together. See you in the next video.